Hello. Oh, looks like everybody's starting to flow in. How's everybody doing? Just doing all right, Brittany? Just all right? You got 3 exams this week? You got this. Just stay positive and keep working really hard. Have a positive mentality. Think of it as like exciting. Think of it as being exciting. It's a challenge. You get to challenge your mind. All those exams will put a pressure on your brain, but once you do it, your brain will get smarter. So you'll get even more intelligent, which will help you in your life and in your future career and everything else. All good. Cody's doing good. Pretty good. Joshua's doing good. It's been a long week. Yep. I've been working all day. Get ready to work some more in math. Lots of overtime at work and then homework. Well, it's a good thing that at least you guys can not have to drive somewhere and just watch this at home, right? There's a silver lining to things. Okay. So I felt like we didn't get through 2.7 that much, and that is the last section that will be on your exam that we haven't covered yet. So we're going to do that first before we move on to 3.1 and beyond. Before I start, is there any questions? You guys do know you will be having an exam coming up very soon. Hello? I hear some noises. I don't know if that was a question or whatnot. Is it going to be on Sunday like the syllabus says? Yes, you can check out your class calendar. All you gotta do is go to the class, click on view calendar. You'll see all the due dates. On Saturday, 2.5, 2.6, and 2.7 homework are due. Everything else has already passed the due date. On Sunday, it says exam 1 review and exam 1 are due. It also shows that homework 3.1 is due. That is, I will be pushing that back to the following week. I'll do that immediately right now so that you don't have to worry about the test and that assignment. Work for exam number 1, submission folder. Okay, yeah. So all that is due for you guys prior to the exam is 2.5 homework, 2.6 homework, and 2.7 homework on Saturday. Then on Sunday, exam 1 review, and any other work that is due will be due for you guys. How's that sound? Is it going to be on Sunday like the syllabus says? Yes. Yes. And I believe it's an appropriate time to take it because we would have covered all the material. Actually, today, we can spend reviewing for the exam, whatever questions that you have about previous sections. But once we're done reviewing, I'm actually going to move on to what will be on exam number 2. So let me know, because if you guys would like, we could spend the whole class reviewing for the exam. I want to do what's best for you guys. Wow, that is huge. Oh, you mean this thing? Yeah, it holds a gallon, but it doesn't have plastic. I usually drink out of the plastic jugs, but this thing holds a gallon and it's made out of metal. I don't want all those plastic tasting plasticizers, the bisphenol A. I don't want that in my body. I like to drink out of like a metal can. Plus you could put ice in it. The more review time, the better. Cool. Arm curls all day. You know, Albert, I don't really do curls as much as I should. I should probably do more curls. I should probably isolate my biceps more. Definitely need better triceps. Definitely need better lats and chest and everything else. But yeah, I should probably do more isolation. But anyways, yeah, we can spend the whole time reviewing if you guys like. I don't have to move on to what's going to be on the test number 2. I want to do what's best for you guys. And I believe taking the whole time to review would be that, if that's what you want. If people feel like, oh, I've mastered this material, let's move on, why don't we? Then if that's what you want, that's what you'll get. So I'm here to serve you with my mathematical abilities. I'm here to serve you guys. Nowhere near mastered, right? So yeah. Let me know. What we'll first do is we'll go over 2.7. I'll thoroughly review that. Then we'll start an official review where you guys can ask me anything. Ask me, hey, can we go over this chapter? Can we go over this kind of problem? I want help using the quadratic equation. I want more examples of completing the square. I want more examples having to do with absolute values, stuff like that. Okay? So I'm here to serve you guys. I'm here to humbly serve you. I want to help you guys do excellent in math, and I want you guys to learn math at a level that you've never understood before. Because of the educational system in Oklahoma, I grew up here, born and raised in Oklahoma. I know how awful the education system is here, and how, in turn, the most difficult subject in the world, mathematics, would then get treated so awfully that you guys, everybody hates math because nobody understands math. And of course, you're going to hate something that doesn't make sense and you're forced to do. Of course. But under my wing, I hope that you guys love math and enjoy doing it and appreciate it. And hopefully, I want to influence you to go become mathematicians. If you don't do that, that's fine. But that's going to be what I'm going to be lobbying for. Nowhere near mastered. Yo, ain't ever lied. Yeah, for real. I grew up hating math. The teachers did not explain, and when I asked them to justify what they're saying, they wouldn't justify it. They would just say, "Do it because I said so." I don't vibe with that. I don't vibe with that at all. I don't like being told what to do. Nobody does, really. Can you go over interval notation? Can I get a grasp of how to write it? Absolutely. I can talk about that. I can review 2.7. The order in which we do it doesn't matter. The fact that you have asked, let's do interval notation, I want to honor your request, Elijah. Interval notation. Okay, an interval really is just a piece of the real line, right? So let's say I'm at -2, and I want the piece of the real line that includes -2 and everything beyond it. Well, interval notation says that, okay, I put brackets because it includes -2, and I put a parentheses all the way to infinity. This really is like something without motivation. So why don't we do something that motivates it with like domain? Domain. You guys asked to find domain and range? Yeah, okay. So let's talk about domain. Let's say my function f of x is equal to 1 over x. All right. What is the domain? Because now we can practice finding the domain and writing things in interval notation. Okay. The domain is the set of numbers that we can plug in into this function that allow it to work, that nothing messes up. So for instance, like f of 1 works because then I get 1 over 1, which is 1. F of 2 works. Hello? Someone's talking into the mic here. Okay, I think it was Audrey. All right. F of 2 is when I get 1 over x, which is 1 over 2. That's fine. 1/2, 1. Those are all allowable outputs. But what about f of 0? F of 0 gives me 1 over 0. And who here thinks that dividing by 0 is allowed? Is division by 0 allowed? No. And you guys know why. We've done it together. We've proved why dividing by 0 cannot work. It causes mathematical inconsistencies. So plugging in 0 causes something to mess up. And as a matter of fact, that's the only thing that would cause this to mess up, is if x is equal to 0. So our domain is everything but 0. And so how do we write that in interval notation here? We say that, okay, all the way to the left, negative infinity, approaching 0, okay, but not including 0. That's why we put parentheses. Union, then from 0 to positive infinity. Okay. This union just means take different pieces of the real line. So, for instance, let's say I have a real line, and I want to represent, here's 0, -4 to -1, and not included 1 to 5. How would I represent this piece of the real line in interval notation? Well, I would say bracket -4 all the way to bracket 1. Union, that means add it to this piece, parentheses 1 to 5. Okay. Let's do another domain example. What about f of x is equal to the square root of x minus 1 divided by 3? How about this? Well, in this situation, we can't really divide by 0 because what's in the denominator is always 3. It's permanently 3. So it will never somehow turn into a 0, and we'll never be dividing by 0 because of that fact. But in the numerator, notice we have a radical. We have an x minus 1 in the radical up there. So we have to ensure that this piece never becomes negative, because then we'd be taking the square root of a negative number, which results in an imaginary number, something that we don't want to do in this class. In other math classes, we actually want to do it, but in this class, we don't. So we set what's inside that radical greater than or equal to 0. The reason it can equal 0 is because I can take the square root of 0, that's equal to 0, and then I'd get a 0 in the numerator, and 0 in the numerator is okay, because then the overall fraction becomes 0. There's nothing wrong with that. Okay? So notice that I can solve for x, and I get x is equal to this. So how do I translate this inequality to a interval notation? The best way to do so, the way I advise, is to draw the real number line, locate your point of interest, which is 1, realize that 1 is included because x is greater than or equal to 1. So it's included, so I'm going to put brackets. And since it's greater than, x is all of these numbers to the right. Okay? So if x is all the numbers to the right, and we want to do this in set interval notation, we will call this bracket 1 all the way to infinity parentheses. Does that help answer your question? Yes, it does. Thank you. You're very welcome. Okay. Any other specific questions? Because I still need to get to 2.7, going over that more thoroughly. And then while I'm doing that, maybe you guys could come up with more questions. And once I'm done with that, which won't take very long, it'll probably take 15, 20, 25 minutes. Then we can get to review for the rest of the class for everything else. Okay. So let's do solving inequalities. I think we did enough of this. This is 2.7. This is the last section that will be on the exam. Let's do like 3x minus 2 greater than or equal to 1. This is a question. It says for what possible values of x will this inequality hold? Okay. For what values of x will this inequality hold? So clearly, if x is like a negative 10, this won't hold. See, look, if x is negative 10, that implies that I would get 3 times the negative 10 minus 2. That should be greater than or equal to 1, right? But then I get negative 30 minus 2 is greater than or equal to 1. Then I get negative 32 is greater than or equal to 1. Is this true? No. Negative 32 is not greater than 1. So x equals negative 10 is not a solution to this inequality. We want to find all of the values that satisfy this inequality. Every single x we can plug in that will cause this to hold true. Well, we can find it through algebraic manipulation. I can add a 2 to both sides to get this. All right. Then I can divide both sides by 3 to get this. So there you go. Any x that is equal to 1 and greater will satisfy this inequality. For example, if x equals 2, notice that now I get 3 times 2 minus 2 should be greater than or equal to 1. I get 6 minus 2 should be greater than or equal to 1. I get 4, which is greater than or equal to 1. Cha-chink. So our mathematics allows us to discover every possible value of x that would satisfy that inequality. So then representing this in interval notation, all right, first step is draw your real line, and typically we like to put where 0 is at. hear someone talking. Is that you, Jay? Oh, okay. If you guys have questions, let me know. All right. Okay, so the first way to do this is write your line, your real line out. Okay, once you do that, then let's find the point of interest, which is 1. Then we notice that x is equal to or greater than 1 for these values. So we put a bracket and we'll put some squigglies to mark that, okay, it's including 1 and everything to the right. So in interval notation, this just represents this. So this is what we call the solution interval. This guy right here is the solution interval. It's a set. It's a set of all values that would satisfy this inequality. Okay. So that's that. Let's kick it up a notch and make it a little bit more complicated. What about like 3x minus 5 greater than or equal to negative 17x plus pi? Oh no! It's a number that is a symbol, but it's really a number. What are we going to do? Well, we're going to treat pi like we would treat the number 5 or 6 or negative 13 or 7. It's just a number. Don't be scared of it. Okay? So what we're going to do is we're going to add this 17x to both sides. So I get 20x over here. All right, and then I'm going to add the 5 to let it hang out with that other number. Okay? So I can solve for x by dividing both sides by 20. Boom. Here's our interval. Here's our interval. Okay, here's r. Here's a real line. Here's 0. Where is our point of interest? Well, our point of interest is pi plus 5 divided by 20. I don't know what that number is in my head. Pi is a number slightly greater than 3. Pi is approximately 3.14159 with infinite repeating digits. So, you know, we can plug this into a calculator to tell us what this might be. Pi plus 5 divided by 20. This number is approximately 0.40. So our point of interest, if this is 0 and this is 1, this number is like right here, around 0.4, right? Then our mathematics shows that x has to be greater than or equal to this number, and it includes it. So we put brackets here, squigglies, all right? And then we write that, okay, this means that this is the interval, the solution interval. You could have just as equally wrote it like this, and I as a mathematician would be actually more satisfied. But because you guys are answering your questions online, make sure to input it the way they ask you to input it. I as a mathematician would count these to be the same. But your computer is sometimes is very finicky, it's very fastidious, and it requires you to answer. It requires your inputs to be in a specific way. Okay. Does that make sense? Okay. Well, I want to do is just one more example here. What about 13x over 2 plus 9 is greater than 2x minus 1. Solve for x. Solve for the interval solution. Solve for all the x's that work in this inequality. So what we do is we let the x's hang out with each other and let the numbers hang out with each other. So I get 13x over 2, and I'm going to subtract the 2x from both sides. And I'm going to subtract the 9 from both sides, so I get this. I just subtracted a 9 from both sides, that's there. And I subtracted a 2x from both sides, which is here. Okay. So over here, this negative 2x is divided by 1. So I have to establish a common denominator. So I multiply top and bottom here by fancy number 1, which is 2 over 2. Okay. And then I combine them all into the same denominator. If that was too many skipped steps, here's all the steps in detail. Okay, this is all over 1, so I have to multiply top and bottom by fancy number 1. This 2 over 2. This becomes 13x minus 4x all over 2, all over 2. Notice if they have the same denominator, we can just write it all over 2 and say this is 13x minus 4x is greater than negative 10. All right, that's what we would have gotten here anyways. All right, this is me filling in the steps. So then 13 minus a 4 is 9x over 2 greater than negative 10. So I want to solve for x, so I got to multiply both sides by 2. So I get 9x is greater than negative 20. And I want to know what x is alone, so I divide both sides by 9. So I get x is greater than negative 20 over 9. 20 is the same thing as 2 times 10. Yeah, that doesn't break down. So that's as simple as it gets. That's as simplified as it gets. So let's figure out what the interval is. So we'll draw our real number line, put a 0 over here. What is our number in question? What is negative 20 over 9 approximately? Well, 9 can go into 20 approximately once, 9, twice, 18. So it's just a little over 2, like some 2 point sum. So here's negative 1, here's negative 2. It's a little over 2. Our negative 20 over 9 is right here. Right? It's a little over 2. Specifically, if we were to plug it in and specifically find out negative 20 over 9, yeah, it's like negative 2.2, all right? It's like negative 2.2. So yeah, it's a little to the left of 2, negative 2. It's a little to the left of negative 2. Our x has to be greater than that value. So our x is greater than that value, not greater than or equal to, but greater than that value. So we put a parentheses. We don't put a bracket, we put a parentheses. And if it's greater than, it moves to the right. So it's those values to the right. Meaning in interval notation, we will express it like so. I wrote negative 20 over 9. I could have written negative 2.2. It's probably better to keep it in exact form, the way I have it, negative 20 over 9, instead of using a decimal approximation. Okay, it's saying we're slowly running out of time. We got 10 more minutes before we have to exit out and re-enter. Just warning to you guys that that's going to happen again. It's just very annoying. We deserve better than that. We over here trying to do math and they making us do this, but you got to work with what you got. You can sit here and complain, or you can just accept that that's how it is, move on. and do the best, do with what you have the best. And the most successful people in life do that. They don't sit there too much and complain about what's going on. They just say, okay, this is how it is. I'm just going to accept it and move on and work around it. Okay, let's see what else we got here. Let's work with compound inequalities. So let's say I have a 2/3 x minus 1 is sandwiched between these guys, -5 and -1. What is the set of values of x that would hold this inequality true? So what I do is I add a 1 to all three sides, making this a -4. This becomes a 2/3 x, making this a 0. Right? Then what do? Well, I have to actually multiply all three sides by the reciprocal 3/2 if I want to solve for x. Because 3/2, when it hits this term, makes it into a 1, so I just get x. But when 3/2 hits this term, it becomes a -12/2. And when 3/2 hits this term, anything times 0 is just 0. And notice that when we simplify, bringing the calculation up here, I get that this is -6. So here we go. We get that x is sandwiched in between -6 and 0. Meaning for whatever numbers between -6 and 0, if I plug this into here, it will satisfy this inequality. It will land between this -5 and that -1. So how do I express this in integral notation? Well, we draw our real line, we put our 0, and we look at our points of reference. We already put 0. There's our -6. It's saying x can range between -6 and 0, but it can't include them. So notice that means we got to put parentheses, right? And this shaded region inside here is the integral in which we speak of. And so we can represent that like this with parentheses. Any questions so far? Excuse me. Any questions so far? I know you guys are still in here. Let me check. Participants. I got 16 participants in here. Carrie said no. No, sir. Nope. Good. Okay, good. Because you're not here in person, I can't see you like nodding your head or anything like that. I'm sure you guys are taking notes and being really good students. But once in a while, I like to like get some feedback to see if you guys are like still alive, if you're still there. I do nod my head still. Yeah, but I don't see that, Carrie. I was nodding my head. Yep. Okay. All right, now let's talk about absolute value inequalities. I kind of touched on this a little bit last class period, but we didn't do it that much. I kind of had to like, for some reason I felt like I had to cover it, but I forgot. I forgot that today we had this whole class period to cover that section. So I was moving a little too fast. But at least that allows us enough time to review. So we have more time to review, okay? So let's talk about the fundamental theorem of absolute values before we do that. The fundamental theorem of absolute values states that if I have the absolute value of x, and that's less than or equal to some number, let's say a, what that implies is we get this. Gosh, that chalk is getting in my nose. And there's nobody in this room, so don't worry about all this stuff, right? Oh, thank you. Okay, that's what the fundamental theorem of absolute value states. Okay, so it seems kind of weird right now, but why don't we apply it to a situation to see what that's talking about? So how about, let's try and solve this. Absolute value of x minus 1 less than or equal to 3. The fundamental theorem of absolute values applied to this situation right here states that this implies I get negative 3 less than or equal to x minus 1 less than or equal to 3. That's it. You get rid of that absolute value by doing that, by applying the fundamental theorem of absolute values. Okay. Then I just solve for x. I add a 1 to all 3 pieces here. This becomes a negative 2. This becomes a 4. Aha! So the set of all values that range between negative 2 and 4 is what we're talking about. So if we draw a real line, here's 0, here's my negative 2, here's my positive 4. It includes them, so I put brackets. So this interval is this region right here. So in interval notation, we get bracket negative 2, comma 4, close bracket. Okay, what about another example? Okay, and why don't I put a negative on that 4 here? Let's apply the fundamental theorem of absolute values here. Notice that then we get over here like that. Okay, so this was a negative 4, so we left it negative. And over here it's going to be a negative 4, which is a positive 4. So I add a 3 to each, subtract the 3 from each of the pieces. So I get 1, x, negative 7. Okay. So notice that this is saying that x is less than negative 7, but greater than negative 1. So take a look at what this is saying. It's saying x, so we can separate this into two different things. This is saying x lies between 1 and negative 7, but it doesn't include them. But notice this is kind of weird. This is saying that negative 7 is greater than x, and that x is greater than positive 1. Okay, so if you think about it,